Hamza, are you getting my voice?
Sir,
Okay. So today we'll discuss the actually today we'll discuss the telescope. Okay. Today we will discuss telescope. So what is a telescope? What is the use of telescope? Basically, if you want to see the distant object like moon, stars, planets, these objects are very far from us. So if you want to see those objects which are very far from us, then telescope is used to see those objects. Okay, so basically a telescope is a device that helps us, or you can say it helps us to see the distant means the objects which are very far from us, distant. Okay, distant object like moon, planets, stars, etc. clearly. Okay, so telescope helps us to see the distant object clearly. For example, distant object means the objects which are very far from us, like moon, okay, like planets. Planets also are very far from us, like stars. Stars are also very far from us. Okay. Recently in news there is one telescope. Okay. So James Webb telescope. Okay. Now after that, I told you when we were discussing the simple microscope, visual angle. Suppose this is your eye, and this part is the retina. Basically, retina is that part of the eye where the image is formed in eye, and retina behaves like a screen. Okay, means on a screen the image is formed. In the same way, on retina, image is formed. Okay, this is the image. Now, if this is the object, this is the object. So this object will sustain some angle at your eye, and that angle is known as the visual angle. That angle is known as the visual angle theta. Okay. More will be this visual angle, more bigger will be the image of the object. Okay. So what is the visual angle? Angle subtended by the object at eye. Angle subtended by the object at eye is visual angle. Angle subtended by object at eye. So this angle is subtended. You can see here. This angle theta is subtended by this object. So this angle is known as the visual angle theta. So more value of theta, bigger will be the image. After this, we'll come to the magnifying power of telescope. Magnifying power of telescope. Basically, the magnifying power of telescope is represented by capital M. Okay, is represented by capital M. And this is the ratio of visual angle formed by the final image divided by visual angle formed by the object. Magnifying power of telescope is visual angle formed by the final image divided by the visual angle formed by the object. So visual angle formed by the final image is represented by beta, and visual angle formed by the object is represented by alpha. Okay, visual angle formed by the object is represented by alpha. So you have to remember what is the visual angle. Okay. Okay. Now after this we will discuss refracting telescope. Basically there are two types of telescope. One is refracting telescope that we will discuss today, and there is another telescope, reflecting telescope. Okay, so today we will discuss the refracting telescope and we will solve some of the questions on that. Basically a refracting in a refracting telescope. So this is a refracting telescope. In this, this is a bigger objective lens. This is the objective lens and this is the eyepiece lens. Here the eyepiece lens as compared to the objective lens is smaller. This is the eyepiece lens. Okay, this is eyepiece lens and this is the objective lens. Objective lens is bigger, eyepiece lens is smaller. So the purpose to make this objective lens bigger is that because we know that we want to see the objects, we want to see the objects like moon, like stars, and those objects like moon or stars are very far from us. Okay, so we want that from those objects more amount of rays should be collected here. Okay, if the aperture or the size of the lens will be bigger, the rays their the amount of rays collected by the lens will be more. Okay, that is why the objective lens, okay, purposefully we make it larger. Okay, larger means for example I can give the example also. If the focal length of objective lens is 100, if you can say the focal length of this eyepiece is suppose 5 centimeter, so the objective lens focal length will be 100 centimeter. Basically it is 20 times bigger or it is sometimes 15 times bigger than the eyepiece lens. Okay, so now you can see here objective lens is of large aperture and large focal length, means objective lens is large. Why? So that it can collect more light from distant object. From distant object means like moon, like the planets, etc. Okay, so that it can collect more light from the distant object. Now we will do. Now we will see the image formation by the uh, object by the telescope. Basically, this is the telescope, and in this telescope we have one objective lens, large focal length, and large aperture, and we have one eyepiece lens. This is the eyepiece lens. Okay. Now these rays are coming from the distant object. Distant object is at a distance of infinity, because distant object, what is the distance of it? Like moons, like planets, they are very far from us. So we can consider those objects are at a distance of infinite distance. So if the object is at infinity or infinite distance from that object, rays are parallel. Object and infinity will give parallel rays. So these are the parallel rays from distant object. These are parallel rays from distant object. Now this is the objective lens and this is a convex lens, you can see here. These rays are parallel rays. Okay, so these rays are parallel rays, and this ray is uh, passing from the optical. This is the optical center, passing from the optical center, and it will pass straight. Another parallel ray is like this. After passing from the lens, it is converging here, and both the rays are meeting at this point here. So, of the distance of this distant object, the image will formed here. Okay, where both the rays are meeting, here the image will form of the distant object. So you can see here the image is formed. This is the image formed, and this image is formed by the objective lens of distant object. This image is, suppose I am giving it a name A dash, B dash, E dash and B dash. And one more thing, parallel rays always meet at the focal plane. So basically these rays will meet at a point, and that point will lie on a focal plane. So basically this point will be the focus of objective lens. This point will be the focus of the objective lens. One more thing, now I think it should be clear to you that rays are coming from the distant object, and this is the objective lens, and this objective lens is forming the image here, and this image is a diminished image, smaller than the object, very smaller than the object, and this is the eyepiece lens. This is the eyepiece lens. Okay, so of this eyepiece lens, this is the focus of the eyepiece lens. Okay, here is the focus of the eyepiece lens. So this combination is adjusted in such a way so that the image is formed between the optical center of eyepiece lens and the focus of the eyepiece lens, between the optical center of the eyepiece lens and the focus of the eyepiece lens. Okay, so basically this is the image, and this image is formed between the optical center of eyepiece lens and focus of the eyepiece lens. Now in microscope also we have seen that the image formed by the objective lens is working as an object for the eyepiece lens. Here also this image formed by the objective lens will work as a virtual object for the eyepiece lens, or you can say this image will work as an object for this eyepiece lens. Okay, we can mark the distance now. This distance from here to here, this distance will be the focal length of the objective lens. This distance will be the focal length of the objective lens. Okay. Now from here to here will be the object distance for the eyepiece lens. From here to here, this distance will be the object distance for the eyepiece lens, because this is the object for the eyepiece lens. Now for this object, this eyepiece lens will form image somewhere. Okay, so now see, for this object we will form image. Now this final image will formed by the eyepiece lens. Now we have this object and we have this lens, and image will form, and this object is in between the optical center and the focus of the lens. Okay, so first ray from this is parallel. Okay, from this object is parallel, and if this is parallel, then it will pass from the, okay, it will pass from the second focus of the eyepiece lens. Okay. Another ray from the object is like this, is passing from the optical center like this, and it will pass straight. It will pass straight. Now you can see both these rays are diverging rays. Both these refracted rays are the diverging rays. Now these diverging rays will never meet. Okay. These diverging rays will never meet in reality. So what we will do, we will produce these diverging rays in the backward direction and we will get the image. So now we will produce this diverging ray and this diverging ray in the backward direction and we will get the image somewhere. Producing the diverging rays in the backward direction. Somewhere here you will get the image. I am making these produced rays with dotted line. So these diverging rays when produced backward will meet at a point and at that point the image will form. Basically here this is the point where the image will form. This is the final image. This is final image. This is the final image. Understanding, Hamza?
Yes, sir.
Okay. So basically, of the object which is very far from us, you are getting this image, final image, and this final image is formed by the eyepiece length. What happens initially? Rays are coming from the distant object parallelly, and these are passing from the objective lens, and objective lens is much bigger in size. Okay, and this objective lens is forming the image at the focus, or you can say at the focal plane of the objective lens here. Now this image will work as a virtual object or object for the eyepiece lens. Now this eyepiece lens will form the image of this here. So final image is this. Final image is this. So basically in this way, in the telescope, you will get the image. And now we will calculate the magnifying power. Okay. Now we will calculate the magnifying power of the telescope. Now for the magnifying power of the telescope, what was the formula? The magnifying power of the telescope you can see here. Visual angle formed by the final image divided by the visual angle formed by the object. Okay, this is the magnifying power of telescope. Visual angle formed by the final image divided by the visual angle formed by the object. Now, what is the visual angle formed by the final image? So, where is the final image? This is the final image. This is the final image. Talking about the angle, so you can say this angle is the visual angle formed by the final image, that is beta. Okay, this is beta. Your eyes will be somewhere here. You will see the image. So actually this angle will be suspended on your eye. Okay, so this will be beta, visual angle formed by the final image. Now visual angle formed by the object will be this, alpha. Okay. So these rays are coming from the object, so this will be object. In this case, your eyes will be somewhere here. Okay. Now, if this angle is alpha, so you can say this angle will also be alpha, vertically opposite angle. Okay, vertically opposite angle. So this angle will also be alpha. Now, magnification is beta by alpha. Magnification is beta by alpha. So we can find it easily. Now, we know that this image A dash B dash is very small. Okay, this image is small. So if this image is small, then you can see this beta and this alpha will also be small because these angles are related to this image. These angles will also be very small. So you can say alpha and beta are small angles. Alpha and beta are small angles. Okay, alpha and beta are small angles. Why? Because this image is very, very small. So if alpha and beta are small angles, then in that case, we have one assumption. Mathematically, we can write tan alpha approximately equal to alpha, and we can write tan beta approximately equal to beta. Okay, if this is only possible when alpha and beta are small angles. In that case, tan alpha can be written as alpha, tan beta can be written as beta. After that, first we will find tan alpha. Now, how we will find tan alpha? See this triangle. This triangle. See this triangle. This triangle. Okay. So in this triangle, tan alpha we can find. Tan of any angle is perpendicular of the triangle divided by base of the triangle. So tan of this alpha will be perpendicular of the triangle divided by base of the triangle. Base is this distance. And what is this distance? This distance is FO. And what is this distance? This distance we have assumed A dash and B dash. So tan alpha is basically perpendicular, that is A dash B dash divided by FO. Now we can find tan beta also. Now for beta, see this triangle, this triangle. So in this triangle, tan beta can be find it out by perpendicular means A dash B dash divided by this distance, and this distance is UE. So A dash B dash divided by UE will be tan beta. Okay. Now I told you tan alpha can be written as alpha. So you can write alpha is equal to A dash B dash divided by FO. Tan beta can be written as beta. So you can write A dash B dash divided by UE. Now with the help of alpha and beta, you can find magnification. Magnification is beta by alpha. Beta by alpha. So beta is A dash B dash divided by UE. A dash B dash divided by UE. And this is divided by alpha. Alpha is A dash B dash divided by FO. A dash B dash divided by FO. Now this A dash and B dash will be cancelled out. So finally the magnification of the telescope will be FO divided by UE. Okay. This will be the magnification of telescope. This will be the magnification of telescope. FO, what is FO? Focal length of objective lens. What is UE? Object distance for eyepiece length. Object distance for eyepiece lens, you can see here. This is FO and this is UE. Okay, so after this we will have two cases for the magnification. First case we will take for the maximum magnification. If you want the maximum magnification, then in that case the final image will be formed. Final image will be formed by the eyepiece. We know final image is formed by the eyepiece lens, but that final image should form at a distance of 25 centimeter, means at a distance of D. Okay. What is D? D is the least distance of distinct vision. D is least distance of distinct vision. Okay, and this is equal to 25 centimeter. So what is the meaning of least distance of the distinct vision? Means the least distance up to which our eye can see the object clearly. So in this case, in case of the maximum magnification, the final image by the eyepiece should formed at D. So now the final image is forming at D. So you can see here, this is the eyepiece lens. This eyepiece lens is forming the image at a distance of D distance. So this distance you can say is D distance if the image is formed at D. So if you will find out this distance, means you will measure this distance in this direction, but the incident rays are in this direction, means D distance you will take negative. Okay. So image distance you will take minus D. Object distance, object is here with respect to eyepiece, and you will measure the object distance in this direction, but the incident rays are in this direction, so UE also you will take negative. So and focal length is the focal length of eyepiece lens. So you can apply the length formula, 1 upon V minus 1 upon U is equal to 1 upon F. So 1 upon V is 1 upon minus D. Okay, minus 1 upon U is minus UE. Okay, this is minus UE is equal to 1 upon FE. From here, I want to find the value of 1 upon UE. So this is minus, and minus minus, it will become plus. So here you will have 1 upon UE, and this is minus 1 by D. When this minus 1 by D will go this side, it will become positive. So basically you will have 1 upon UE is equal to 1 upon FE plus 1 upon D. So the value of 1 upon UE you will get 1 upon FE plus 1 by D. Now you can find the magnification. Magnification of telescope, we find it out. Focal length of objective lens divided by UE. It will be focal length of objective lens, and 1 upon UE. 1 upon UE is this. So you can multiply this. So from here you can take FE common. So you will have F naught divided by FE 1 plus FE by D. So this is the formula for the maximum magnification. FO by FE 1 plus FE by D. FE is the focal length of eyepiece lens. FO is the focal length of objective lens. D is 25 centimeter. M is the magnifying power. Now second case, normal adjustment or Lext eye. So when there is a normal adjustment of the telescope, the final image will form that infinity. Means infinity means at some far distance. So this in this case, final image for the normal adjustment final image will form at infinity. Final image will form that infinity. Means the final image formed by the eyepiece is at infinity, means the image distance V is infinity. And object distance will remain same, that is equal to minus UE. And focal length will be focal length of eyepiece. Now apply the lens formula 1 upon V minus 1 upon U is equal to 1 upon F. And 1 point, remember 1 point 1 by infinity is equal to 0. So you will have 1 by V means 1 by infinity. It is 1 by infinity minus 1 upon U means minus 1 upon UE is equal to 1 upon FE. Actually, now in this case, final image is forming at infinity. So you can see from here, this eyepiece is forming final image at infinity. Means image distance you will take infinity, object distance will remain same. That will be UE minus UE, okay? So 1 by infinity is 0, minus minus plus. So you will have 1 upon UE is equal to 1 upon FE. One upon UE, you will have 1 upon FE. Now you can find the magnification. So magnification for the telescope is equal to focal length of the objective lens divided by the object distance in case of eyepiece lens. Okay, so the magnification you will get FO, and 1 upon UE you can write 1 upon FE. We will get FE. So this will be the magnification in case of the normal adjustment. And this magnification is minimum magnification also. And this magnification is the maximum magnification. Understanding, Hamza?
Yes, sir.
Okay. Now summary. Overall, what we have discussed is summary. So you can see the magnification of telescope was FO by UE, focal length of the objective lens. UE means the object distance for the eyepiece lens. In case of the maximum magnification, where the image formed at D, image is formed at D, and what magnification we get? M is equal to FO by FE multiplied by 1 plus FE by D. And one more thing you have to remember here in this case. In case of the maximum magnification, if someone is asking from you length of telescope, length of telescope, that is L. So length of telescope is basically the distance between the objective lens and the eyepiece length. That is equal to FO plus UE. You can write in mod FO plus UE. I am writing in mod because distance can never be negative. Now this is the length of the telescope. Now in this case, if you want to find the length for the telescope, it will remain same. But here UE is equal to FE. Here the value of UE becomes equal to FE. So the value of UE is equal to FE. You can put here. So length of the telescope in this case will be F naught plus FE. Okay. So in case of the normal adjustment, the length of the telescope becomes F naught plus Fe. Focal length of the objective lens plus focal length of the eyepiece lens. So this thing I have written here. Length of the telescope in case of the maximum magnification FO plus UE. Now in case of the normal adjustment, final image is formed at infinity we know, and what the magnification we get FO by FE, and what is the length of telescope F naught plus FE. Okay, take the screenshots. Done. Take these screenshots. Hamza took the screenshot.
Yes, sir.
Took. Hamza took the screenshot.
Yes, sir.
First, take the screenshot. This whole screenshot. Okay. Now again take the screenshot. This whole working of telescope basically this is. Taken?
Done, sir.
Okay, okay. Now take this screenshot.
Sir, done.
Okay. Take this screenshot.
Done.
Okay. Take this screenshot. Done?
Done.
Okay. Done this also. Do this also. Do this.
Done.
Do this. Now we will solve numerical. Now take the screenshot and after this we will solve numerical on the same topic. Done? Done, Hamza? See this numerical. In this numerical, they are saying a refracting telescope is under normal adjustment. A refracting telescope is under normal adjustment and its magnifying power is 5. If the length of the telescope, okay, under this condition is 150 centimeter, and it is given that final image is formed at infinity. Find FO and FE. Find FO and FE. Now this is the condition of the normal adjustment. We will see first what is given data. So you can see magnifying power is 5, means magnifying power is given. Length of the telescope is given as 150 centimeter. And we have to find focal length of the objective lens and focal length of the eyepiece lens. Now this is the condition of normal adjustment. Now you can see in case of the normal adjustment, what is the magnifying power? FO by FE. And what is the length of telescope? FO plus FE. So we will use these two formulas. Okay. So magnifying power is 5. So okay. Magnifying power is FO by FE. So FO by FE is equal to 5. So from this, I will get FO is equal to 5 times of FE. Question number 1. Now length of telescope is FO plus FE, and that is equal to 150. So 150 is equal to FO plus FE. Okay. This is your equation number 2nd. Now put the value of FO in equation number 2nd. Solve equation number 1st and 2nd. Okay. So from equation 1st and 2nd, it is 150 is equal to FO. Instead of this FO, you can put 5 times of FE. Plus there is one more FE here. So it will be 6 FE is equal to 150. So FE will be 150 divided by 6. Now cancel 150 and 6 with 3. So it will be 50. It will be 2. So FE you will get 25 centimeters. FE you have 25 centimeters. Now you can get FO. Basically FO is 5 times of FE. So it will be 5 multiplied by 25. So FO you will get 125 centimeters. Okay. FO you will get 125 centimeters. So in this way you have to solve the question. Take the screenshot. Done. Done. Hamza, done.
Done.
Okay. Okay, next question. Can you do this question by yourself, Hamza? Try this question. Read the question first.
Yes, sir.
Just try this, and you have to apply the formulas, and you have all the formulas. I have given all the formulas to you. You can check your notes, and you can just try to solve this question. You should try to solve this question. I will solve the question, but at least you should try. Okay, see, it is given focal length of the objective lens of a refracting telescope is 100 centimeter. 100 centimeter is the focal length of the objective lens. This is given. Focal length of the objective lens 100 centimeter given, and that of eyepiece is 5 centimeter. Means The focal length of eyepiece is also given. That is 5 centimeter. If the final image is formed at least distance of the distinct division, means final image is forming at D. So what is the condition when final image formed at D? Final image is formed at D means this condition, image formed by eyepiece is at D, means the case of the maximum magnification, means you have to use this formula for the magnification. Okay, for the magnification you have to use this formula because this is the case of the maximum magnification because the final image is forming at D. Okay, now any other data? Okay. So this data is given. They are asking if the final image is formed at D, find magnifying power and length of the telescope. So magnifying power, for finding the magnifying power, we have uh, this formula in this case. Okay. So we can find the magnifying power. Focal length of the objective lens 100. Focal length of the eyepiece 5. 1 plus FE is 5 and D is 25 centimeter. Okay. D is equal to 25 centimeter. So from here, when you will solve, you will get, when you will divide 100 with 5, you will get 20. And from here you will get 6 by 5 because this 5 5s are 25. 1 plus 1 by 5 means 6 by 5. And 5 4s are 20. So magnifying power you will get 24. Now after that, length of telescope. What is the length of telescope in case of the maximum magnification case or when the image is formed at D? Is this. Length of the telescope is this. FO we have, but we do not have UE. We do not have UE. So now we can find UE. We know that final image is formed at 25 centimeter. So it will be minus 25 we will take because we will measure the distance in the opposite direction of the incident light. After that, object distance, we will have UE, minus UE we will take. Okay. And focal length of the eyepiece length is 5 centimeter. Here we can apply the length formula, 1 by V minus 1 by U is equal to 1 by F. 1 by V, it will be 1 upon minus 25, okay, minus 1 by U means minus UE is equal to 1 upon 5. So from here you will get 1 upon UE is equal to 1 by 5 plus 1 by 25. So you can take 25 LCM. So you will get 5 5s are 25 plus 1. So you will get 6 divided by 25. So UE you will get 25 divided by 6. 25 divided by 6 is 6 for the 24 and you will have 10. So 6 ones are 6. You will have 40. So 6 6 are 36. Again you will have 40. It will be 4.166 centimeter. So UE you will have 4.166 centimeter. Now length of the telescope is FO plus UE. Length of telescope is focal length of the objective lens plus UE, and this is the length of the telescope in case of the, when in case of image formation at a distance of d by the eyepiece length. So length L, you want to find FO, focal length of the objective lens is given 100 centimeter. So it is 100 plus UE. UE you will have 4.166. 4.166. So length of the telescope you will have 104.166. Okay, this will be the length of the telescope you will get. This is the length of the telescope and this is the magnifying power. 24. Length of telescope is 104.66 and this should be in centimeter also. It is centimeter also. Okay, Hamza, understanding?
Yes, sir.
So you have to apply this formula. Why we are applying this formula? Because it is given the image is formed at least distance of distinct division, that is D. When the image is formed at D, that is the case of the maximum magnification. And for the maximum magnification, the formula of the maximum magnification or magnifying power F0 by Fe 1 plus Fe by D.